Okay, ladies and gentlemen, it looks like our audio is up and running. Good for us. All right, let's go over here. Let's kind of look at what we were doing. Polar coordinates. So, do you guys remember what do we have on Monday? Monday is what? Test 4. All right, so I'll send you guys some information about test 4, like a study guide in Canvas for you. I'll let you guys know about that. It is Monday the 22nd. And then the following week is your final exam on Tuesday, May 30th at 7 to 9 a.m. Just to kind of remind you guys about what's happening here. So anyway, ladies and gentlemen, we're getting down to the wire here. So, all right. All right, so now if we go to our worksheet video and library and we head out to, here we go, where are we at? Polar coordinate and conversion here. Okay, let's put that in the chat. So we want to be able to convert, believe it or not, and you might say, what do you mean convert? So this is, if we have already downloaded that this morning here, that kind of worksheet for you, these notes, just want to express to you guys that yes, you do have the rectangular coordinate system superimposed over the polar coordinate system, and of course they share the same location. Right? So we focused yesterday on plotting points r theta. And that particular location shares the same location in Cartesian. Remember, rectangular coordinate system. So you got the circular coordinate system over rectangular coordinate system. That P shares the same location, but if you notice, it forms a right triangle. All right, so you go, wow. So is there a relationship? The answer is absolutely there's a relationship between the two. So ladies and gentlemen, there is that relationship. So let's kind of read through and say, wow, what is this? Superimpose Cartesian, the XY plane, also known as a rectangular coordinate system over the polar coordinate system. Right? You say, hey, good morning. I got to double check our audio. Yeah, our audio is there. Good. And our audio is there. So, okay. So good morning to all of you. We superimpose a system over each other so that we can describe curves with less sophisticated algebra. This is really the point eventually for us. Okay? We want to describe really curves with a lot less sophisticated algebra. That's really the game plan over this sort of conversion idea. Okay, we'll see this shortly. But for now, we want to be able to convert points between the two systems to eventually convert curves between the two systems. So we want to investigate this conversion a little bit. Okay, just investigate it a little bit because we're going to actually look at how this relates to polar curves. So here we go. We use right triangles or right triangle properties that we already know and love. These are known as the conversion formulas. And you say, what do you mean? Well, go back over here, right? We know already the definition of tangent of that angle theta is y over x because this is opposite over adjacent. And you go, oh, that's right. Okay. We also know by the Pythagorean theorem that x squared plus y squared is r squared. So remember, the polar world has the equations r and theta. You got r, you got theta in the polar world, right? So here's your theta, and here's your r in the polar world. So you guys are aware of that, right? The rectangular world has these coordinates x, y. So you say, wow, those are the same x, y's? Yes. So we use essentially geometry. We use geometry to see the relationship between the two coordinate system, the XY plane and the polar coordinate system, where r and theta come from polar and y and x is rectangular. So these equations we know and love. We've been working with this stuff since, again, oh, you say, what topic is that? That's really geometry, but this is also trig. Right? So this is quadrant 1, which is geometry. It's our reference quadrant. And, you know, you extend this to trig, quadrant 2, 3, and 4. You guys know the drill by now. And there you go, ladies and gentlemen. There it is. So there's the relationship. Now, I summarize this here for you guys again. And yes, x can't be 0 because we can never divide by 0. So these are what we call the conversion formulas. Okay, so we're going to start by doing a little bit of conversion. You know. So, ladies and gentlemen, let's try to go with an example of what this conversion is about, right? This conversion of points. So they may say, okay, how do we start to convert the following polar coordinates, r theta, to rectangular coordinates? So you're going to convert polar, which is right here. So you say, is this polar? Yes, that's what they mean. That means this is r and this is theta. Okay? So r is 3, theta is pi over 4. So we're going to convert polar now to what? To rectangular coordinates. What are the coordinates in terms of x and y? And of course, they want us to plot the location. So we did that yesterday. You said, okay, pi over 4 is in fact 45 degrees. So we know that's between 30 and 60, right in the middle. Okay, so this is the stuff we worked on already, but the radius is 3 now. So you say, how do we get the radius of 3? Well, it's 1, 2, 3. So ladies and gentlemen, we did that part yesterday. This is the location of that point P in polar form. This is what we're looking at here. All right, so that's the polar coordinate location. So you go, okay, nothing's changed, but what's new, and I think, oh, we do have some space. What's new is this conversion. We want to know, what is this location in terms of x and y now? And in order to do that, we have to use these what? The conversion what? Formulas I just described to you guys. Right? So we got to use this here. So we go, okay, tangent theta, y over x. So let's write them down. So you're going to say, okay, we know tangent theta is y over x. And we also know x squared plus y squared equals r squared. So plug in these values into your equations. R is 3 and theta is pi over 4. So you go, okay, let's plug those in. R, here's my R. There's going to be what here? A 3. And then your theta is what? Pi over 4. So what this says is y equals x tangent pi over 4. Now, what you guys should know here at this point, I'm going to move this out of the way. What you guys should be aware of is what is tangent of 45 degrees? You guys know what that is? Tangent 45 degrees, we know is going to be the number what? 1. So this says y over x is the value 1. Okay, you guys okay with that? And if you said, okay, then multiply both sides by x, we get this relationship that y equals what? X now. Easy peasy lemon squeezy. So you go, okay, well, what do I do now? Well, you also know by the Pythagorean theorem that x squared plus y squared is 3 squared, or we say x squared plus y squared is the number what? 9. You guys okay with that? Just by plugging that in. So here's our two relationships we're going to start to work with in algebra. You go, oh my God, the algebra problem again, right? So what do we do now? What do you guys think we do now? We got these two equations, y is x, and we got this x squared plus y squared is 9. What should we do? Do you guys know what we do? What we can do is we can replace our y value with x. We substitute. You say, what do we substitute? Well, since y is x, we have x squared not plus y anymore, plus another x squared is 9, which means 2x squared is 9, right? So if I divide both sides by 2, we're going to get x squared is now 9/2. So does anybody know what do you do with this now to find that value, right? How do we get x? What do you guys use from algebra? We've been using this. You're going to use the what? Square root formula. Outstanding. So you guys know. Use the square root formula. Okay. So x will now be plus or minus square root of 9/2. We have to now do our algebra here, right? We got to simplify this by properties of exponents. I'm sorry, not properties of radicals. Excuse me, I'm not awake. And then you say, well, what do I do with that? Do you guys remember what we did with that? We did this kind of algebra before. We rationalize the denominator. And so now that means x is plus or minus 3 squared root of 2 over 2. So, ladies and gentlemen, you have multiple solutions here. You say, well, what does that mean? Well, what do we know? X is plus or minus 3 squared root of 2 over 2. And what is y? Y is the same thing as x. So you say, okay, plus or minus, plus or minus what? 3 squared root of 2 over 2. So you have this 3 squared root of 2 over 2 for y as well. That's the y value. So here's what I'm going to go back up and show you guys here, okay? Because your solution for x and y here, in theory, x is plus or minus 3 squared root of 2 over 2, and y is plus or minus 3 squared root of 2 over 2. All right, you guys have the same values. However, here's what you guys want to be aware of. What quadrant is this point in? Do you guys know? You see the point we plotted in the rectangular coordinate system? What quadrant is that in? That's quadrant 1. What do you guys know that's special about quadrant 1? This is something you guys always want to remember. Quadrant 1, what do you know? X is positive, good, and Y is positive. Is that right? Since that's the case, that solution for both X and Y coordinates are positive, ladies and gentlemen. This is what you're looking for. Okay? So you got to go back and use a little bit of that algebra, the substitution principle, and you could now give this location in Cartesian coordinate system the XY plane. This is what they want you to do, convert polar to rectangular. So this is the process of conversion here. You know, it's kind of interesting. I'm kind of looking at your book here, and it doesn't look like they give an example of that, in all honesty. Let me see if they ask you questions here. Yeah, they say find the rectangular coordinates. You know, so they ask you questions, but I don't think they give you an example. That's kind of weird, unless I'm reading it wrong. But I'm glad I'm showing you guys how to do that. What do you guys think? All right. We're going to try that one again. Okay, we're going to go through that algebra again. They're giving you here, so you guys know, what is this? That is polar coordinates, where the radius is 2 and the angle theta is pi/6, which is 30 degrees. So to plot that point now again, remember what we did yesterday. Okay? The radius here, this is 30 degrees. Is that true? Isn't that pi/6, 30? And then what's your radius here? 1 what? 2. So that's the location. Again, this is a quadrant 1 point where both your X and Y coordinate values are going to be what? Positive again. Is that right? So I just want to let you guys know ahead of time. Just think about that. Quadrant 1. Okay. Here's R, here's theta. All right. Okay, so they say, what do we got to do? We got to convert to rectangular again. And in order to do that, you're going to use your conversion formulas, meaning tangent theta is y over x, x squared plus y squared equals what? R squared. Okay, where the theta comes from the polar representation and the r comes from the polar representation. So you say, what is theta? Pi/6. What is r? 2. So substitute. So you're going to say, okay, theta is 30 degrees. R is 2. So you end up with 2 equations. You say, what is this? Tangent pi/6 is y over x. And then the other equation gives you x squared plus y squared equals 2 squared. Okay, so you substituted these values in here. All right, so far so good? So you say, okay, well, what is tangent of 30 degrees? Does anybody know what tangent 30 is? You might say, Mr. Judge, I don't know what tangent 30 is. Anybody know by now? We've taken trig for Ooh, tangent 30 degrees. Doesn't this come from what? 2, 1, square root of 3, 60 degrees, and this is 30 degrees. Double check. I'm not awake yet, ladies and gentlemen, even though I woke up at 4:15, and I did some work at 4:15, so you guys know. So you say, well, what's going on here? Well, tangent 30, what's this going to be? Anybody know the definition of tangent? Isn't it opposite over adjacent? So I think this is supposed to be what? Opposite over adjacent. That 1 over the square root of 3, which is square root of 3 over 3 when we rationalize that denominator. Okay. So let's write this down here. What that means is y over x is square root of 3 over 3, or we can say square root of 3 over 3x. Anyway. All right. Now you say, well, what do I do with this? Well, this equation now here, you say, what is this going to be? X squared plus y squared equals 4 now. Okay. So we solve that equation. What do you guys think you do with this like you did before? You want to substitute that y with what? Square root of 3 over 3x. So you're going to substitute. So, okay, algebraically speaking, you get x squared plus square root of 3 over 3x squared is 4. And that means x squared is, what's that going to be? It looks like 3/9 x squared is 4. Right? Doing some algebra there. And 3/9, by the way, is really what? 1/3. So I'm kind of looking at your book, and I don't even see them doing examples of this kind of conversion, so you guys know. So it's kind of weird why did they give you questions even, and yeah, find rectangular coordinates for the polar coordinates. So they ask you questions without these examples anyway. All right. So you might say, well, how do I do what? How do I add on the left side? Well, replace that denominator with what? 3. So this is now 3x squared plus 1x squared over 3 is 4. And I'm going to have to go get some space here. 4x squared over 3 is 4. So you say 4x squared over 3 is 4. So you guys can multiply both sides by that 3, and you get 4x squared is 12, looks like. Yep. Divide by 4, we get x squared is what? 3. So you say, what do I use now? Square root formula gives you your x going to be plus or minus square root of 3. All right. So I'm going to have to erase some work here. Okay. So I'm going to erase some work. You guys either have that in your notes or you have that in the video here. Let's erase this because we need space. Okay. So let's go back and we go, okay. We got the x coordinates. How do we get y? You say, how do we get the y coordinates now? We'll plug this in here to y. Y square root of 3 over 3 now times the plus or minus square root of 3, right? Because that's what x is. Y is the square root of 3 over 3x. So you might say, what does that mean about my y? Well, whatever it is, it's plus or minus. Take the square root of 3 times square root of 3, we know is 3. It's divided by 3. So y is plus or minus 1. Bless you. Now remember, a solution here is a xy coordinate. And so you might say, well, which one is it? Because x is plus or minus square root of 3, and y is plus or minus 1, because this is the values you just got, right? We know x is plus or minus square root of 3. We know y is plus or minus 1. So let's go back here and take all of our solutions right up here. And let's recall a very important detail. In quadrant 1, what do you guys know again? X is positive and y is positive in quadrant 1. Is that true? So, what's your final answer? Take the positive square root of 3 for x, positive square root of 3 for 1, and ladies and gentlemen, you have converted your polar coordinate to a rectangular coordinate, meaning that location can be described as square root of 3, 1, but it also can be described in terms of polar as 2 pi over 6. Okay? So just to kind of go over this concept of converting for you guys, and I don't even think your book gives you an example of this. That's kind of crazy. That's crazy that your book wouldn't give you an example. I'm looking at your book, and I'm trying to take a look at this. Let's take a look at number 3, because that's going to be interesting too. This conversion here, okay? Converting points. Now, it kind of is an important process, but I'll share with you guys some other things here with it. But anyway, all right. So they gave us a polar representation again, okay? You say, what did they give us? Well, the first value is your radius. So they're going to say your radius is what? 1. And the angle is what? 2 pi over 3. Okay. Let's get rid of this. So what did we do? Where is that location? Because that's going to be important for us to know. Where's that location? Do you guys remember? It's quadrant 2. Is that right? What's the angle, though? It's 120. So I want to share with you guys something like this. The radius is 1. So this is the location they're talking about, right? So it's a 120 degree. So this is my radius 1. And that's 2 pi over 3 here. That's the location. And yes, that's in quadrant 2. What do we know about quadrant 2? Well, in terms of your Cartesian coordinates, in quadrant 2, remember x is negative and y is what? Positive. In quadrant 2. All right. That's the location that they're talking about. I don't need to put the address. It's there. I'm just going to put the letter P. Okay, here's your location. Okay, now when you say, well, how do I get the Cartesian coordinates version? Well, here's what you do, ladies and gentlemen. You use your conversion formulas. Tangent theta is y over x, and x squared plus y squared is actually r squared here. So theta we know is 120, right? You say, well, we already know what theta is. That was 2 pi over what? 3. My radius was 1. So when you plug those in, we know we get tangent of 2 pi over 3 becomes what? Y over x. And x squared plus y squared is 1. Tangent of 120 degrees. Does anybody know what tangent of 120 is? Do you guys remember? This is why we went through the exact values. Don't I need to know? What do I need to know, really? Not tangent of 120, right? What's the reference angle here? Isn't that 60 degrees? Don't we know all students take calculus? So tangent's negative, isn't that right? So we just need to know what tangent 60 is. Do we have a 60-degree special triangle somewhere? Darn it, I erased it. Okay. I erased it. I wish I didn't. 60 degrees. Isn't this 2, 1, square root of 3? So what's tangent 60 again? Do you guys remember? Opposite over adjacent. So what that means is tangent 120 has to be what? Negative square root of 3. Is that right? Because it's in quadrant. What quadrant is this in? 2. Where are you at? So negative, we said, well, this is negative what? Square root of 3. Okay. All right. So y over x is negative square root of 3. Solve for y. We get negative square root of 3x. All right, you guys okay with that one here? Just so you guys know, negative square root of 3x. All right. But we also know x squared plus y squared is 1. So you say, well, what do we do now with this? Well, what did we do before? We substituted for the y value. So you get now x squared plus negative square root of 3x squared equals the number 1 here by substitution. So that your x squared becomes plus, that's a 3x squared now, equals 1. Right? Combine your like terms. 4x squared is 1, which means x squared is 1/4. Yet again, use your what? Square root formula. So we're going to do this algebra here, which is x is now plus or minus the square root of 1/4, right? And so if you did the algebra here, you said, isn't that the square root of 1, square root of 4? Isn't that 1/2? And the answer is yes. So your x coordinate will be plus or minus 1/2. All right, you guys okay with that? So you might say, well, what is your y coordinate? Well, plug it in here. Let's get the red out. Plug in for the x here. So y is minus square root of 3 times plus or minus 1/2. Now, you know what that means? The y value is also what? plus or minus square root of 3 over 2. So here's your x and y values, and let's write it together here, right? So you say x and y, what is that? Plus or minus 1/2. And then this is plus or minus square root of 3 over 2. But you need to know again. You say, what do I need to know? What's the deal with this location? What quadrant is that point in? The point is in quadrant 2. So the x coordinate is negative, but the y coordinate is what? Positive. That's just true about quadrant 2. So if x is negative, what's the final answer? X is negative 1/2. Y is positive square root of 3 over 2. So ladies and gentlemen, here you go. This is your rectangular coordinate location for that same point. So you got to pay attention to those little details. I just want you guys to note in quadrant 3, what do you guys note about the location here? Your x coordinate in quadrant 3 is what? X is negative and y is negative. So I want you guys to be aware. So if a point is in quadrant 3, they're both negative. If a point is in quadrant 4, what do you guys know about your x coordinate? Quadrant 4 point has a positive x value and a negative y value. So I just want you guys to be aware, because you use that when you get these plus or minus answers. You're going to use that information always. So it's kind of unfortunate your book didn't give an example. You know, like look at this one, right? You say, what is this? What quadrant is this polar coordinate in? Right? R is what? The square root of 2. What's your angle theta? Isn't that minus pi over 4? So what happens with the negative angle? Do you guys remember? You rotate how? 45 degrees. Rotate clockwise. So this is where, this is that minus pi over what? 4 angle, right? And then square root of 2, do you guys know what square root of 2 actually is? It's actually a little bit bigger than 1. It's like 1 point something. So we're just going to put the point there, a little bit bigger than 1, okay? Square root of 2 is that 1 point, it's like 1.414 or something like that. So it's actually more than that. It's a little bit, almost halfway. We're just going to eyeball it. Ooh. Let's double check. It's like our power's not on. But it was. There we go. Woo. Okay. So isn't this the location, right? We plotted this yesterday. Okay, let's use our conversion formula. You go, what's our conversion formulas? Tangent theta y over x. Tangent negative pi over 4 is y over x. Do you guys know what tangent of a negative pi over 4 is? What is this? Is that negative 1? That negative 1, ladies and gentlemen? So what does that mean? That means y is negative x. Right? We're going to have to plug that in because, what's our radius here? Square root of 2. Okay. X squared plus y squared equals r squared, where your radius is the square root of 2. There we go. So what do you guys do now? What have we done before? We just plug this what? We substitute for the y negative x. So you say, does that give us x squared minus x squared will be now 2? And the answer is yes. So x squared plus x squared is 2. 2x squared is 2. Divide both sides by the 2. We get the nice quadratic x squared is 1. So you say, what do I use now here again? Use your what? Square root formula. So x will be plus or minus square root of 1. We just know the square root of 1 is 1. So we have the plus or minus answers here for x. And now you say, well, what do I do with this? Well, what you do with this here is you plug in what? You get your y's. So you say this is minus plus or minus 1. You know what this gives you? The same thing. A minus times a negative times a positive is a negative, and then a negative times a negative is a positive. Sometimes I write this as minus plus, but that's the same as plus or minus, okay? Just to let you guys know, in case you were wondering what happened there with the arithmetic. So I want you guys to understand, with all of these cases here, you're going to have plus or minus 1 for your x and y values here. Or you're going to have plus or minus. Here's what I mean. The x value is plus or minus 1, y value is plus or minus 1. Okay? So this is the algebra that gave you those solutions. However, you say, my point is in quadrant what? 4. What do you guys know about quadrant 4 again? Your x-coordinate is what? Positive, and your y-coordinates are negative because you're going to the right for this location, and you're going down, right? So if x is positive, that means my solution is positive 1. If y is negative, that's negative 1. So ladies and gentlemen, this is an important detail. Okay, so this does come up. You need to plot the location to know what quadrant it is, because you're going to get plus or minus for x and y values. So I just want to share with you guys, that's the deal there with those here. Okay. Now, you can go through some of the others there. However, I think what we want to do is look at the following, right? We're going to try to convert what now? Rectangular to what? To polar. So this is now going to be x and y values. And really, ladies and gentlemen, these x and y values are actually a lot easier. And your book does have examples there, by the way. Your book has examples of that kind of conversion. But what I'm going to go back and show you guys here is this. Let's go back to the original conversion formulas. Okay, let me do this. Yeah, let's go back over here. Because there's a little bit more to the story when you convert here. See if your book wrote it down. Yeah, your book did write it down. Okay. So there's more to the story. Let me go back here. Let me remind you guys here, right? You also have the definition of cosine of the angle here, right? So do you guys know, if I said to you, even by geometry again, what's cosine here? Isn't cosine adjacent over hypotenuse? For this right triangle, adjacent over hypotenuse, right? So what's the adjacent side? X. What's the hypotenuse? R. So there's more to this conversion. This is X over R. So if you solve for X, we get what? X is R cosine of theta here. That's what we're going to use. So there's more to the story. X is R cosine theta. Now, similarly, what's your definition of sine again here for this right triangle? Isn't sine opposite over hypotenuse? Opposite over hypotenuse? Y over R now? So we could do the same geometry. So you can solve for Y. So R is now sine theta. Okay? So I want you guys to put in your notes this. Y is R sine theta. Now, when would you use this? To convert polar to rectangular. Now you might say why? Because what they're going to give you now is R and what? Theta. You're going to get the X and Y values now with this. This first formula, you say, well, what about the first formula? Well, that's when you convert polar to what? Rectangular. All right. So there's more to this. Right? So you remember this. What did they give you before? I think they gave you what? Polar, theta, and R, and you had to find the green Y and X here. So anyway, so it's much easier to convert polar to rectangular. Let me show you why. We're going to use these conversion formulas here. So, okay, X is R. Let's go back and use these conversion formulas now. And here's the deal. You go, where are we at? There we go. Okay, so by the conversion formulas, we know X is R cosine theta, and Y is R what? Sine theta. Uh-oh. Uh-oh, something's... Do we get our coffee in us here? Oh, I apologize to you guys. Apologize. What we did was fine. However, nope. Yeah, we're converting polar. I apologize here. This is polar what? To rectangular. Yeah, let me share with you guys here. Let's go to number what? 5 here. Okay. Let's go to number 5. These are what here? Isn't that polar? R is -1, theta is pi over 2? Okay. So, R is -1, theta is pi over 2. So, ladies and gentlemen, we can use what here? X is R cosine theta, and Y is R what? Sine theta. This is easier to do. I apologize to you guys. So the first 4, yes, we can do that. We can do that with the first 4. In fact, this is what's done in higher order math courses. But anyway. So for number 5, we're still with the polar. Put R in here. What's R? -1. Is that true? What is theta here? Pi over 2. So we get X is negative cosine pi over 2, and then Y is negative what? Sine pi over 2. Do you guys happen to know what is what is cosine pi over 2? What's cosine of 90? Is that 0? So -1 times 0 is 0. This is your x coordinate. Y, what's sine of 90? Isn't that 1? So y is -1. So x will be 0 and y is -1. Let's verify if this is okay. So how did we plot this yesterday? 90 degrees is right here. Isn't that right? But the radius value is what? Negative. So how did we plot this yesterday? Wasn't this opposite the pole because it's a negative radius? So that's your location P. This is this location here, this polar coordinate. The rectangular coordinate is actually what? X is 0, y is -1. So ladies and gentlemen, we could use this relationship for the polar. So in other words, the first ones we did, we could do it this way. And that's what your book does. All right, so I apologize to you guys for doing that to you, torturing you with the algebra. But that's actually how it's done, you know, as well. Okay, so you guys okay with that? So just let you guys know that. Now you might say, well, how do I actually do this? When they give you rectangular coordinates, well, that's when you use the others. So yes, x squared plus y squared is r squared. Tangent theta is what? Y over x. So these are your x and y values. All right? So if x is 1 and y is negative 1, we say 1 squared plus what? Negative 1 squared is that r squared. Which means r squared is 1 plus 1, or r squared is 2. Right? Do you guys know what the radius is going to be here? If r squared is 2, what do you use again? Here, use the what? Square root formula. So that means r is going to be plus or minus square root of 2. Okay. Sorry about that. Now you say, well, how do I get the angle theta? Well, this is where you use tangent theta is y over x. What is the y value? Isn't that negative 1? What's the x value? Positive 1. So tangent theta will be what? Negative 1 over 1, or tangent theta is simply negative 1. Do you guys know what theta is here? This means theta is going to be what? Is theta pi over 4? What's theta? Right? Isn't that a trig equation? This is why you guys solve trig equations. What is theta going to be? Isn't there 2 quadrants? Let's go back. Right? Remember this? All students take what? Calculus. Where is this location? Where is 1, negative 1? X is 1, y is negative 1. This location here is in quadrant 4. Is that true? Your point is a quadrant 4 location because x is positive and y is negative. So what does that mean about my theta then? What can I say about theta? You guys just got through doing the inverse tangent, or you can use inverse tangent. You can say theta is what? Negative pi over 4. Is that right? Isn't that a quadrant 4 angle? But if theta is negative pi over 4 now, what's the deal? Negative 45 degrees. Doesn't my radius have to be positive if the angle is negative? I have 2 options. That means my radius is positive square root of 2. Okay, so because my point is in quadrant 4. So this answer now, in terms of r and theta, is the square root of 2 negative pi over 4. So this is how we convert, ladies and gentlemen, rectangular to what? To polar. So you're going to have to know a little bit about some what? Some graphing or plotting points. Okay? Just want to let you guys know. So if I go back in our notes, you say, what do we do in our notes with these formulas? This is where you convert rectangular here to polar. Okay, so these are your conversion formulas there. So I apologize to you guys. But this is a way to do it. If you guys say, can I still do it this way? Yeah, actually you can. But, you know, it seems to be algebra intensive. Like, for example, here, they give you a polar coordinate. Just to go back, this conversion, this is polar. We can do it. Right? You need to say, okay, is x r cosine theta, where my radius is the square root of 3. I now need cosine of negative what? 5 pi over 3. Your y coordinate is r now, sine theta, where the radius is the square root of 3. We need now sine of negative 5 pi over 3. Okay? I need space. So I apologize for scaring you guys with some algebra when I could just use this straightforward sines and cosines. Okay, apologize for you guys there. I went with my notes. I did get up too early, but whatever. What's this negative 5 pi over 3? How do I handle this? What do you guys think? You guys have taken trig. What does this mean? Is cosine even or odd? So what does that mean? Can I just say this is what? 5 pi over 3 for my x coordinate? What about for the sine here? What's this going to be? Can I pull out my negative sign? Is that right? Because it's even? You say, what's even? Sine's even. Cosine is what? Odd. What's pi over 3? Is that 60? 5 times 60 is what? 300 degrees. So, ladies and gentlemen, how do I find those answers? If this is 300 degrees, what's the reference angle? That's 60 degrees. And then what else do I say? All students take what? Calculus. So I'm going to need cosine and sine of 60 degrees. Is that true? So you say, what's cosine of the reference? What's sine of the reference? Okay, I'm going over every gory detail. Notice my special triangle here. Do I use a special triangle? Yeah. 2, 1, square root of 3, is that right? So, what's cosine again? Is that 1/2? And what's sine? Square root of 3 over 2 for that reference angle here? Okay. So what does that mean about cosine of 300 degrees and sine of 300 degrees, right? What does that mean here? Because I need cosine of 300. I need that sine of 300. So what do you guys think about this? All students take what? Calculus. Cosine's positive. Sine is what? Negative. Good. You guys know the drill. So cosine will be 1/2. Sine is negative square root of 3 over 2. So ladies and gentlemen, let's see what this is here. So what is my x coordinate? Square root of 3 over 2 times 1/2, or square root of 3 over 2. Maybe you prefer the algebra. your y coordinate is minus, right? So you have y is negative square root of 3. Negative what? Is that square root of 3 over 2? Double check. Okay, so this gives me now what? Y will be positive 1/2. Because then minus a minus here. And you say, what's wrong with this picture? Maybe nothing's wrong with the picture. Let's go back and erase. Let's see if this makes sense. Does that make some sense? Well, where is this point? We plotted this yesterday. My radius is the cube root, square root of 3. What's my angle? Is that negative 300 degrees? So where is negative 300 degrees, right? If I had to plot this. Rotate what? Isn't that negative 270 plus another 30? Ah, that makes a lot of sense. This is a quadrant what? 1 answer. Okay, and what's the square root of 3? Do you guys know what the square root of 3 is? What's that? Let's get out the TI. Second square root what? 3. That's about 1.7. So that's almost 2. So we can say this location is somewhere like over here, right? Almost 2. And that makes sense that both x and y would be what? Positive, right? Because quadrant 1, x is positive, y is positive. So the location will be here. Square root of 3 over 2, 1/2. So maybe you do prefer what? Maybe you do prefer the algebra. Okay? You pick your poison, just so you guys know. But if you go the other way, you go, Mr. Judge, what if they gave me a Cartesian xy value, right? 0, 2. Where x is 0, y is 2. What was the conversion? X squared plus y squared equals what? R squared. So 0 squared plus 2 squared, right, is R squared. And you know what that means now? Or R squared is going to be what? 4. So R is plus or minus square root of 4. Or R is going to be plus or minus 2. We got to be careful. 2 solutions for R. One's positive, one's negative. Tangent of theta is y over x. And then you go, but Mr. Judge, what's the problem here? Anybody know? 2 over 0. X can't be what? X can't be 0. Is that true? All right. So what's the real problem here? We need an r theta. Is that right? We're converting rectangular to polar. Do you know where 0, 2 is, by the way? Where's 0, 2? If you plotted 0, 2, this is on the xy plane. X is 0, y is 2. That makes a lot of sense. So in terms of the polar representation, if I used the positive radius of 2, what does my angle have to be? Anybody know? You're looking at it. What does theta have to be here, ladies and gentlemen? Theta must be what? 90 degrees. That's the location. So then use the positive radius of 2 and the angle being what? 90 degrees here. So there you go, ladies and gentlemen. You did convert from what? Rectangular to what? To polar. So you're going to use the information. Let's see this one. This is going to be what? This is x and y. This is, again, converting what? Rectangular to polar. Use the conversion formula of x squared plus y squared equals r squared, which means 3 squared to 3 squared plus negative 3 squared equals r squared. R squared will be, it's going to be, what's 3 squared to 3 squared, right? That's 9 times 3, 27 plus 9. So r squared will be 36. Square root formula. R is plus or minus 6. We don't know which one it is. Okay. Tangent theta, y over x. The y value is negative 3. The x value is 3 squared to 3. All right. That negative 1 over square root of 3. We're going to have to piece together this information. Where is tangent negative? All students take what? Calculus. Tangent is negative quadrant 2, quadrant 4. Is that right? Where is this location of this point? X is positive, y is negative. X is positive, y is negative now means what? It's a quadrant 4 angle. Is that right? Anybody want to tell me what angle this is? What if you said, Mr. Judge, I'm going to be really sophisticated here. I'm going to make sure my calculator is in degrees here. Okay? And I'm going to find inverse tangent of negative 1 divided by square root of 3. Maybe you said, I'm not going to use that information. Let's see if the calculator knows. What's the problem here, ladies and gentlemen? Let's put this together. Negative 30 degrees or negative pi over 6. Let's put this information together here. Can I do this? Yes, angles can be negative, okay? However, be careful here. If you use the negative pi over 6, 30-degree angle, what radius do you use? The positive or the negative? That's the issue I want you guys to understand here. Which one do you guys use? Positive or negative here? If you use a negative angle, what radius do you use? The positive radius or the negative radius? You have to use the positive radius. Is that true? Because a negative radius would make this opposite the pole. And your point is not opposite that pole. 6. Negative pi over 6. So ladies and gentlemen, I have put together a lot of trig here for us. Going over converting rectangular even to polar for us. And, oh, come on, what is this? Let me double check something. Anyway. $25 to $40. So let's see what this is. 5 to 40. All right. Okay, so ladies and gentlemen, what I just did here, you guys didn't know, I gave you some homework here.